What unique structural or engineering challenges have you faced on those large-scale monorail projects like the one in Nevada? How did you and what were some of the solutions?
There are several items that make a monorail unique. Number one, the geometric concerns. What happens is the monorail beam is a structural member, but also a mechanical one. The second challenge you have is that you need to bring power to those beams, and you need to have mechanical or system devices attached to the beam or close to the beam so that you can have Wi-Fi antennas and you can have a SCADA.
What does it really take to design a monorail that spans cities, crosses continents, and still stands up to extreme environmental demands? Behind every sleek train gliding overhead is a maze of structural challenges, from seismic retrofits to precision guide rail alignments that most people never even see. Joining us today is Carlos Banchik, CEO and Chairperson of the Board of Innova Technologies, and a pioneer in specialty transit engineering. In this episode, we'll discuss how he tackles unique design, engineering, and environmental challenges of monorails, and how engineers can grow into leadership roles without losing their technical edge. We also dive into ESOP, ESOP, or its type of employee stock ownership plan, and how that type of plan empowers emerging leaders in a firm. Before we jump in, I wanted to tell you about our AEC PM Connect event, where emerging and experienced leaders can learn about real-world strategies to drive performance, empower teams, and lead with purpose. Our next event will be on June 10th, 2026 at the Forest Gate Country Club in New Jersey. Visit aecpmconnect.com and register today. I'm your host, Matt Picardal, and this is the Structural Engineering Channel. Carlos, thanks so much for joining us. Can you tell our listeners a little bit about yourself and how you got started in structural engineering and how you got into specialty transit projects like monorails?
Well, that's a good start. I'm originally from Argentina. My father was a civil engineer. He had a construction company, so I was always involved on construction and driving trucks and loaders and things like that. That always is something I like. After my graduation, we came with my wife, also a structural engineer, to the US, and we went to UC Berkeley. We got our masters. She got the Master of Science. I got the Master of Engineering, and then I joined DSL Corporation, a specialty contracting company, and I was working on the special project division, and I started doing people movers. And in 1994, I started doing my first monorail here in Las Vegas, the MGM Valley's monorail. So that was my first monorail. Later on, there was an extension to that project in between 2000 and 2003. And at the end of that project, I decided to start Innova. So just to focus on the type of projects I was working on. During my university years and even during my technical school, I was developing software programs, and what I realized was that was the key to this type of projects. The long projects is not just one bridge, it's multiple bridges, and the fact that we were programming things and relating alignment and structures was a natural fit. So that's how I got started in monorails, that awareness that my talents could be useful.
Yeah, that's really interesting. It's really cool to see how both of you went to Berkeley, became structural engineers, and now you have a company together. I think that's pretty cool. What about you mentioned monorails? So to me, I've never worked on those. I'm sure maybe not a lot of it seems more of like a specialty. What unique structural or engineering challenges have you faced on those large scale monorail projects like the one in Nevada? How did you and
Right.
what were some of the solutions?
Right. There are several items that make a monorail unique. Number one, there are the geometric concerns. What happens is the monorail beam is a structural member, but also a mechanical one. Because once you pretty much make the beam and you join them together, they become the rail for the monorail. And the tolerances, the geometric tolerances are quite tight. So that is the first challenge that you have. The second challenge you have is that you need to bring power to those beams, and you need to have mechanical or system devices attached to the beam or close to the beam so that you can have Wi-Fi antennas, and you can have SCADA antennas, and you can have detectors along the way. So that forces you to start thinking, okay, what the other disciplines need, what the rolling stock needs, what the mechanical and electrical engineers need, the power traction, how you do that. And the fact is, once you do a monorail beam, you cannot start feeding it at whatever you want, because in modern monorails, most of the time you have low tires on top of the guided beam, and then you have guide tires on the side. And in between the two guide tires, you have the power rails. So you need to be feeding all the power from the bottom and leading it into the guideway beams. So early on, you start realizing that you need to be sensitive to the needs of other people. Same thing when you get into a station, the tolerances get very, very close. So you need to figure out how you can tighten your structural skills to make sure that the lifespan of your structure, of every single beam on there, can lead to 100-year lifespans where you can have a usable product. Just to give you an idea, the width of the beams cannot be more than plus or minus 3 millimeters, which is very, very tight. And then in terms of deflection, you have very tight criteria. Just to give you an idea for you structural engineers out there, the ratio between live load and dead load can be between 0.4 with an empty train to pretty much 1-to-1 when you have a full train. So you need to be very careful. We need to be very careful on considering how we post tension beams and how we structure things so that we can provide the level of service we want on the structure. The last thing is how to be sensitive, like I said, to the other disciplines and be able to deliver what they need where they deliver it. So that brings you to learn about manufacturing techniques and how you make construction sequence so that you can come up with constructible methods. And that's something we structural engineers lack for the most part. For the most part, we say, oh, this is means and methods. Well, the specialty that I developed working on back to VSL Corporation was, since we were specialty contractors, we had to focus on how we design it, how we build it, how we construct it in the field, and how you maintain it later on. So that gives you an added level of sensitivity of the whole life of the project. And then with the years, we got involved into the maintenance of it. So you start learning what are the problems of your own designs, and that helps you sharpen the pen. So that's, in a sense, how you get into monorails and how we are where we are.
Yeah, very complex, it seems, in terms of it's not just a beam. It's kind of like the lifeline, right? It's not
Right.
just a structural, it's mechanical, it's electrical, it's the serviceability of the monorail and the people in it. It seems like everything's just crunched into that one structural object, but everyone is using it in some way. It's pretty cool.
And something we learned, Matthew, was many times we structural engineers say, okay, our box is this one, the contractor box is this one. What we have realized is sometimes the contractors don't have all the skills and the sensitivities we have as structural engineers. So that helped us develop what we have at Innova, which is a construction observation team, to help make sure that the methods of construction match our engineering. And that's where that gives structural engineers a relevance that we don't typically have on many projects because of budgets or because of schedule. So I submit to all of you listening that there are opportunities for us structural engineers to become relevant in a project in a way that we don't have many times. And you know what? Don't be afraid of seeking that relevance, saying, this is a service you really need, because not everybody knows how to do these type of things. So it's been an interesting path.
Yeah, really developing on that expertise in terms of not just staying in one box, but hey, we have this expertise, we can easily apply it to these other ones too.
Strong project outcomes need skilled managers and competent leaders. EMI's corporate training delivers expert-led courses in project management and people leadership, plus industry-recognized certification and exclusive premium content to take your team even further. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on Corporate Training.
And for delivering all these infrastructure projects, I imagine you have to balance a lot of things. You got the technical excellence, you got the safety with the cost, sustainability, and environmental constraints. What approaches have worked best for striking that balance for you for these types of projects?
Yeah, I would say engaging on early on with the stakeholders, understanding what their needs are. By this time, imagine I have 30 years of monorail industry knowledge, right? But when I started, I didn't have that. So it is about learning what the power and traction engineers need, what the rolling stock engineers need, what the contractors need, and trying to deliver things for each one of them. It goes from the type of concrete that they need to the flowability of that concrete, the methods of delivering that, the type of forms that you have available, the types of logistics you want to use on a project. So talking to the stakeholders, that's on the construction side. Now you have all the other people involved. You have the urban planners, you have the architects, you have the agencies. Each one of them have their own constraints, and I always think is this is like making a carpet or and using a loom. Each one of those strands is composed of each one of those disciplines, and it is our role as structural engineers, in my case, and I take that very seriously, to create the most beautiful tapestry I can with all those strands that we made, bridging the gaps, making things combine, and when I see things that are stuck in between different groups, trying to bridge those gaps and seeing how we can deliver something, and always being open to new solutions, trying to figure out how we can do better next time and how to deliver, as I said, something that is intertwined from so many different disciplines, right?
Yeah, exactly. It's like in terms of structural engineering, at least for buildings, that's what I'm used to. It's the structure or the final product is similar to a human body. You need structure, obviously the skeleton, mechanical, nervous system, electrical, plumbing. All of that needs to come together, or else it doesn't work. Like
Right.
so all those things need to work in order for it to be a good product or to serve its purpose. I imagine the same thing with monorails. So you need all those things.
Right. So the stations is a good example of what you leave, right? So you have the stations, and then we have maintenance depots, and then you have the guideway itself. So you are
Mhm.
assembling all. Each component has its own characteristics, and just like you mentioned on the buildings, right?
Yeah. And you've also been involved in seismic retrofit projects and alignment-based projects. Can you share some examples of that? And what was it like? Maybe some of the lessons learned working on those complex, multidisciplinary projects.
Right. Early on, I was working with, after I left BSL, I started working with Carter and Burgess, now a Jacob, part of the Jacobs engineering company. I was working on the San Mateo seismic retrofit project. We came up with a frame a precast frame that came in two parts, were assembled over the existing foundations on the approach from the San Mateo side. And that was the first time I was working with Caltrans and working with contractors and builders and people, geotechnical engineers. There were so many interesting disciplines working on the same projects, right? And what was happening was the major problem on that approach to the bridge was the fact that the foundation was very heavy in the baymat. So whenever you have a seismic event, just imagine the foundation is moving and then the bridge is moving even further on top. So having worked on precast on BSL, I was part of the team and I led the team creating the frames, the precast frames that were assembled in the North Bay and then floated up to each one of the bases and then united with post tensioning and grouted and then sank. And what I learned was to listen very carefully to what each one of those people had to say, and how to engage the strength of these new frames that were limiting the movement of these massive foundations that the bridge has. So that was quite a learning experience. It's similar to the experience I had when we were developing in the 1980s the Astronauts Memorial in Kennedy Space Center, and I was the lead engineer on that project as well with VSL. And we had professors teaching optics in Stanford, and the lights of the sun, it was a 55 feet tall by 65 feet wide granite plate, and you can see that today in Kennedy Space Center. And this was
Yeah.
tracking the sun. So the sun was hitting on mirrors on the backside and then reflecting through the names of the astronauts that died on the early 80s on space shuttles. So
This is
you remember the space shuttle that exploded in the 18, it must have been 1987. And what we did was create this. This was paid by the Florida license plates. And this was tracking the sun. And the same thing happens on monorails, working on alignments. So, for instance, on our first large project in Sao Paulo, where we had to weave the monorail into very large avenues at the beginning, but then there were transitions through minor streets to another major highways or roadways. And what I learned was listening to people and try to incorporate what is key for each one of them into the solutions. And that is what led to each one of those projects being a success, just trying to understand what they're saying and leading to a point where you can put everything together in something that can be easily understood by the construction crews on the field, right? So those are the
yeah.
commonalities on these specialty projects that I've been part of.
Yeah, for those, it seems like since they're more complex projects, it's not just something that, you just pick up a book and it shows you how to engineer it. It's like using your engineering skills on exactly what they're used to. That's why you get them on a project that's not an easy solution and requires engineering. And for things like that, it's not just in the engineering, but like you were saying, everyone on the team listening to each other, seeing what the problems are, everyone can learn from each other on those types of projects. So yeah, that's pretty cool. And I know you had really varied. You worked on various locations throughout the world. I imagine you're working with different codes, standards, stakeholders, and even just some of the cross-cultural and cross-regulatory environments. Like,
Right.
how do you navigate that? Can you tell me a little bit about that process just from working with different all across the world? What have you seen?
Yeah, we are blessed to have projects in South America, Southeast Asia, North Africa, Central America. We've worked on many proposals, even on Southeast India.
Yeah.
What has always learned is study the country, the culture, the history where you are developing the projects and trying to understand what is their regulatory framework. Having done that, then we try to identify local talents. Like we know our staff, we are structural engineers. So what we try to do is tell our clients we need a very experienced civil engineer to help us with traffic and transit issues on any of the projects that we are dealing. And then we try to identify structural engineering talent, many times professors or people that have their own companies that have been practicing on that market for a long time. So with that, we start assembling and assessing what the risks are on different portions of the project and assessing each one of those risks. When it comes to our part, we bring our international codes like AASHTO, AEC 21, and what we have been developing in the International Monorail Association for the last 10 plus years, 20 years, since 2011. So, and I was fortunate to be president of the company, the International Monorail Association for 10 years. And we sensed that there was a need for monorail codes and standards and guidelines. So we developed a bunch of them through time as well. So we bring this international knowledge, there is a local knowledge, and we try to merge them into load combinations and loads that can, in a sense, fit within the AASHTO framework. And then we're working with the AEC 21, where we are very active participants also. We came up with a load combinations, and we tried to feed all of that into that. And then we automated a lot of these processes so that we can quickly assess the reliability of the guider beams and the substructure. So that is the way we have done it. Now, does it end there? No. Why? Because, for instance, when I was in Sao Paulo, the first thing I learned in the first meeting was many of the people I was dealing with did not speak English. So I tell you what, in the next first 6 months of the project, I had intense immersed in Portuguese culture and listening to radio, reading Portuguese magazine. Coming
Wow.
from a Spanish background, I was able to understand some of the commonalities and be able to learn Portuguese. And that
Yes.
allowed me to be much more effective than just going through all the things that I mentioned before. Because if you cannot speak the language, we have a problem. So in the case of Cairo, obviously learning a non-Latin language like Arabic would have been very, very hard. But I learned certain words that helped me understand where the conversations were. And I was blessed to having people like Dr. Fargal Marie and others in my team that do speak the language and do understand what our needs are. So, we build bridge for living, but we build bridges for understanding between different communities and cultures. And I think that's the sensitivity that we can develop, and it's a very fulfilling thing when you can operate in that and see that what is the value that we bring into a project, right? By understanding what their needs are, being able to communicate with them at their same level, and seeing the results through time.
Yeah, I think that's really cool. It's like you're saying, it's the work that we're doing. It's not just if it gives you a chance to see what the impact of that project is going to be, particularly for that area or that country or that sector, where you may not, it may be different than where you're at currently, but once you get immersed in their culture, you can see why there's that need for that type of structure. What about climate change and CO2 emissions? What roles do you see monorails and special transit playing a role in this building sustainable cities?
Right. We've done in-house studies and compared monorails with light rail or heavy metros, elevated, right? So there is a point in a life of a city, megapoly or cities trying to connect with each other, that require elevated or separated, great separated solutions. So either you go underground or you go above ground. We also studied the underground impacts. We can say with total confidence that the amount of concrete that we have on a monorail structure is 40% less than a comparable system using a large deck and steel rails. That's because
Mm.
the grace of the two guideway beams or one guideway beam, whatever it's the system you have, and there is no much redundancy. Like I said, your structural element becomes the mechanical element. So with that, there are some responsibilities, but 40% less concrete, 10% less steel, and those in terms of material. Now, the big advantage we have is the speed of construction. In projects like Cairo, we were able to build, once you have the environmental and construction permits approved, and you have design criteria accepted by your agency, we were able to build the East of Cairo project. That's a 100-kilometer project. One phase goes east of the Nile, the other phase goes west of the Nile. Well, the phase east of the Nile was 55 kilometers between Cairo and a new capital city. We were able to build that in 55 kilometers, which is about 36 miles, in about 36 months. 36 months for building that. The project is still going on stations and some specialty structures, but the guideway itself was done in 36 months. That's 1 mile a month. And
Yeah.
that is about 1,500, 1,600 meters a month. Those are numbers that are difficult to comprehend unless you are involved in a project and you are involved on so many facets of it, from using concretes that you've never worked before, like flowable concrete, for doing 5-part beams or columns, sorry, some of them up to 17 meters tall, 20 meters tall. That's more than 60 feet tall just
Yeah.
for the column itself in one shot. In one shot. That requires specialty forms, that require specialty handling of the stresses on the, and then you have to have the steel bars on top of those structures precisely in the geometry that you needed. And we were able to do that thanks to a very creative team on the contractors that were working on that project. So those are the limits of your creativity. You can do as much as you can with a partner willing to take the bullet and say, okay, we're going to do better now than we did before. So that in terms of materials and construction techniques and the speed of construction. So those are the things that really provide monorails with an advantage over regular structures. And I don't want to even talk about the fact of this is much more efficient than a tunnel with all the
Yeah.
problems that you have building tunnels, right, on a city.
Oh yeah, I
You
can
can see
imagine.
that in Los
Hmm.
Angeles, okay,
Oh yeah.
uh,
Yeah.
with what's going on and the time that it's taking.
Oh
So,
yeah, I could see. I had a question related to that. You were mentioning construction methods for monorails. For the rails and the beams themselves, are those usually precast concrete beams, or are they cast in place?
right, most of the time they're precast. You need
Oh, that's why they're
specialty
quickly,
forms.
huh?
Yeah, you need specialty forms. There are a number of suppliers. The one that we use the most these days is an Italian company. They have what is called the carousel type form. So they have several stages. The fact is, you can do a beam a day on one of those systems. There are different techniques for curved beams. You can imagine that a curved beam is, if you had no super elevation, on a curved beam, you would have a cylindrical shape on each side of the guide beam. Now, once you have a super elevation, now your guide beam is not longer a cylindrical shape on the sides, but it becomes conical. So early on my career, I developed a program that allows us to understand what is the geometry and the super elevation, linking AutoCAD with spreadsheets. So that is what allow us to have, even today in our engineering, fast access to geometric data that we use, and then we keep track of all those things. So that is what makes monorail technology something unique in a sense, because you need to be conversant in so many different aspects of the technology, but it gives you great pleasure once you understand how you do it. Going up to the level of how you finish a beam, and we are working. We have worked for the last year on a work group with the International Monorail Association to come up with a paper, a guidelines for, and we had the cooperation of Michelin and Alstom and many practitioners on our industry coming up with that project. Dr. Zoltan Rado with his aviation experience on pavements, and Eric Berger in Michelin with his knowledge on the type of things that they look in pavements for tires. So those are the things that make a monorail something, as I said, it's a mechanical device, and you need to understand how you make it. So I don't know if it was too much of an answer, but I think I tried to hit the points that you were trying to make.
No, that was cool. It's because like you're even going into all of the, it's not just a structure, even the way you finish a beam. It's kind of like an art, right? Where it's not just, oh, it's just free surface. No, there's all these things that go into it. The alignment, the slight curvature or of a post-tension beam, how does that work? And all the geometries that go into it and all the
Right.
mechanical, electrical, plumbing.
So going back to your question, yeah, going back to your question, these monorail beams, when you have them on the curve forms, they can have horizontal and vertical curves. So you have a form that is able to
Yeah.
cast a piece of very complex shape to very tight tolerance. The tangent beams, most of the time, the forms are such that you can do tangent beams and vertical curves only on them. But on the curved beams are really something to tip our hat on to, or to the mechanical engineers that devise them. And then you need to have all the geometry to adjust the form to what your beam needs, right? So your beam might be 20 meters in length, but your form is 36 meters. So your goal is to give that 36-meter form the shape so that your 20-meter beam comes out exactly how it needs to come.
Yeah, the constructability is a whole nother thing too.
Right.
Those types of projects. I want to transition to some of the business aspects. So you've led your firm through transition to ESOP or ESOP ownership. I believe that's employee ownership. Can you talk a little more about that and what made you choose that route and how does that empower your employees?
Right. Many years ago, we started thinking how we keep the team together. So, and then at the same time, how I can transition out of the business and leave things working. So there are many avenues to it, and one of them was saying, okay, we sell the firm to somebody else, and then we stay on board for so many years, and then I leave, and then the team is there. And I've seen that transition going on some of my companies that where I worked before, and I didn't like the feel of letting something that you have nurtured and created with your team be left to the decision of somebody else that had the financial power to buy your firm. So we started many years ago thinking, okay, if we need to sell the firm or if we need to transition into an ESOP, the needs are the same. That means we need to develop a leadership. Why not to develop a leadership internally so that our own team can benefit of having a strong company? And so that decision was made with my wife, that is part of the company management or leadership. And so we started training people and empowering people in a way that we can create that leadership. So I've been blessed with having my wife, Adriana, and Rob Naples join the firm in 2007 and create independent groups from the transportation group that I was leading as a president of the company. And they created independent groups within Innova. And my role at that point was empowering them to become leaders on their own and develop their skills that they already had into becoming the leaders that they are. Today, I'm glad to say that Rob Naples will be, or is the new president of Innova, and he's looking forward to growing the leaders that we have grown since 2007. And it takes a long time to acknowledge in your organization wants to take that role, the role of leadership. So what we have done is support those that want to take those roles into courses given by other firms on project engineering, project management, CO training, CFO training, and then having them attend peer groups here available in Nevada or in Montana, where some of our key members are, and start learning what professional and business growth is needed to lead a company. So I think we are in the business of empowering future leaders, and that is what defines the way we have dealt with our staff for the last 20 years. Always looking to empower the future leaders, because that's all you have as a structural engineering company, the talent that you are able to bring and nurture. I don't know if you've gone to SeaWorld, but there is those famous shows where you see the killer whales going through the hoops, right?
Yeah.
And I remember early on, I don't know if they are still doing it because it might be that nowadays is considered animal cruelty, but I remember attending them and they were saying, how do you train a killer whale to be able to overcome their fears and go feet above the water and go through these rings above the water? And they say it very clearly. First, they start underwater with the ring, and then when the killer whale goes over the ring, they give them some fish, and then they start bringing the ring up, and it is the same. They are mammals,
Yeah.
by the way, and
Gradually.
we are
Yeah.
mammals. Okay, so the same things that a killer whale can do, we can do in our own companies. Start training people early on, giving them the power to make decisions, and then taking the ring out of the water.
Yeah, I think that's awesome in terms of you're investing in their leadership. And with that employee ownership structure, they all have a stake in the company as well, right? In
Right,
terms
right, right. We are in the
of
process of
employee ownership,
finalizing the
it's their
ownership.
company too, technically.
Exactly.
And I think that's great. Yeah, it's I know some firms may or may not, depending, I guess it depends on what firm. I've talked to a lot of people, different types of firms, where sometimes they may just get promoted without any leadership training, right? Going from a technical role to maybe just a manager or business role without training just because. And then I think it's cool that you're investing in their leadership skills by actually showing them like, hey, here's first you spot them out, and then like, okay, they want to be a leader. Well, let's get them trained up, right? And it's kind of just like you were saying, gradually, and it's up to them. But you're helping them achieve that through investment, not just through promotions, but investing in their education. So I think that's really cool.
Right.
Looking at individual careers, I think engineers sometimes may have have a struggle to balance technical and leadership throughout their careers. What advice would you give to those aiming to grow as leaders without losing their technical edge that they've developed as engineers?
Yeah, that's a good question because deep inside, especially we structural engineers like to we want to go deep, most of us, into things and
It's,
keep our technical edge, right? And
yeah.
many years ago, we were opening the Bellagio here, open in town, and we went and saw that marvelous hotel, and I saw all these chandeliers up above, and they were done by Dale Chihuli's studios up in Seattle. And I thought, wow, this is amazing. I cannot believe how they can do these many things. Well, learning from his experience, I realized that he had evolved his technical knowledge into developing the leaders, and now he was leading a bunch of artists into creating all of those things. And they created, I don't know, I think there are hundreds of those chandeliers there, and each one has the feel of each individual artist that work on it. And I thought, structural engineering is about the same. We can develop our leaders into having each one of them their individual flavor. Some of them are more technically savvy. Some of them want to go into AI. Some of them want to go into programming. Some of them want to go into leadership and assembling teams and running them effectively. And I thought, you know what? That is the challenge of that we have as human beings, to become and understand what is the purpose and meaning, the things that give us purpose and meaning in life. And then I said, you know what? I shouldn't be afraid of letting some of my technical skills go, because I'm learning new skills of how to develop this team into the true potential. So there are things that you keep based on your training and all the things that you have done close to your vest and close to your chest. One of them is construction sequence. The other one is easy of assembly. The other one is how elegant the solution is, and how fast you can get to a solution, the constructive solution, and how safe it is to erect, right? So those are the things that I look at nowadays on our packages and our calculations. And I tell them, listen, I'm not going to check your torsion calculations or unless it doesn't make sense, right? Like recently we had a question from one of our clients, and they said, oh, we're having some bearings that are having some traction. And I said, this is an error with a model. And so that's something that our younger generations, and maybe at, at the beginning of my career, I was trusting too much the model, right? But when you have a model and reality tells you something else, we better adjust and say, okay, this is not reality. The reality, the model needs to adjust to reality. So I quickly told my team, guys, go back and look, because this is a problem on the model. This is not a problem on the bearing. And that was the feedback, and they quickly identified, yeah, one of the supports was modeled not as a pin, but it was modeled or not as a simple support. It should have allowed the beam to have vertical motion and not have traction. My advice is to everybody out there that wants to follow this route is, don't be afraid to grow into leadership while keeping your technical instincts sharp. okay? At the end of the day, what comes out of your firm has your signature, has something you have worked for many years. So again, don't be afraid to go grow into leadership and while keeping your technical skills sharp.
Yeah, that's great. It's like you were saying with the leadership aspect of it, you have your own expertise, but the ones that you're leading or that are you're grooming them to be leaders, they have their own expertise too. And essentially, if you guys are a team, that whole expertise as a firm, because of that leadership mindset, now you have all the collective expertise of everyone on the team to help with the firm. So yeah, I think that's pretty cool.
So, Matthew, we're talking about how to keep your technical skills and how to transition into the leadership, right? So,
Mhm.
as being part of the monorail industry, we realized there were no scanning methods easily accessible to the contractors and to the operators to be able to assess what is the width of the beam, the perpendicularity between the top of the beam and the sides of the beam, the super elevation of the beam, and the location of the beam on every location. So 5 years ago, we started developing in-house a self-propelled scanning tool for monorails, and we have started recently, starting last year, to test that in several locations. And I have to tell you that we recently completed a very successful deployment in one of our projects where we scanned a number of sections of a monorail and got great results. And we have a great team understanding what the results are. And it was not something where we structural engineers had all the keys of the puzzle. We work with great companies in the field of profiling, great companies in the field of automation, and with our own internal team, we were able to assemble. We became technology consolidators to come up with this vehicle that runs at 5 miles per hour and scans the guideway beams every 25 millimeters every inch. There is no instrument right now that can allow us to do that, and it gives actionable data for a contractor to fix the beams where they need to be fixed. So this is a great step for the industry, and that was started from a structural engineering company. So I can imagine many of the people that are listening to this have similar challenges on other industries. And I just invite them to open their eyes to what opportunities are there to strengthen our structural engineering knowledge and the communities where they work and the industry that we are part of. So again, don't be afraid to grow into leadership while keeping your technical instinct sharp. So that's my main message.
That's a great example. Do you have any final piece advice that you'd like to share with structural engineers inspiring to make an impact in the environments?
Yeah, thanks. I think that's a great ending for this conversation. And I thank you for having been doing this podcast and having so intuitive and inquisitive questions. I have to say that we are not alone in the world. We are stepping on the shoulders of other people that brought us to where we are. And we hope to continue growing the community, our instructional engineering community, into higher and higher grounds, right? And things that we think that were not able to be done in the past. So I was blessed to have great leaders in the past that brought relevance and value by the advice they gave to contractors and other engineers and their clients. And I looked at that and I said, you know what? This is about being relevant on what you do. So many times I tell my own people and my own children, there are three ways you will find three types of people in your professional and life. Some of them will be relevant, some of them will be irrelevant or even negative, and some of them will be indifferent, right? So relevant, irrelevant, and indifferent. And what I always tell our younger engineers and my own children is try to see how you can become relevant if that's what you would like to do in your life. And it all depends on, again, your wants and needs. There is nothing that says that you cannot live a meaningful life in whatever career and whatever pursuit you would like. I think that the Maslow pyramid of needs has reflected my way of looking at the world and trying to see getting to the top of it where we can get things that get purpose and meaning to what I have done as a professional, as a father, as a member of the community. And my advice to them would be, if you so choose, to develop your skills to the point where you are relevant in whatever project you are part of. Trust your voice and participate. Bring value to the table, and that will be opening many doors to successful interactions and beautiful projects to come.
That was beautiful. Thanks, Carlos. Yeah, I think that's great right there. Just because I wanted to touch upon when you're talking about the meaning. When I talk to engineers that have been in this industry for so long, a lot of it comes down to that purpose, that meaning, being valuable, being skilled at what you do. And by being an expert, bringing your expertise to the table, you, like you were just saying, becoming valuable, but also that value brings meaning and purpose to, because what we do is we're not just doing things and they never get used. The stuff that we build, the stuff that we engineer, getting used by a lot of people. And if you could look at the purpose about that, I think that's great advice. I think it's, looking back, I see a lot of professionals that have become successful use that type of advice to drive their work. So thank you for that. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.